Hi everyone. In this video, we're going to be doing A Level Maths 9709, paper 33, Pure Maths 3, May June 2025. This paper is 1 hour 50 minutes long, so we'll try to finish within that time limit. So without further ado, let's get started. Okay, so for the first question, we're told to sketch the graph of y equals to the modulus of 3x minus 2a, where a is a positive constant. Okay, so in order to construct a modulus function, let's first draw our axes. So this would be our x-axis and this would be our y-axis. And now we should locate our x and y intercepts of the normal curve line y equals 3x minus 2a. So the y coordinate, just substitute x equals to 0, you'll get y equals to minus 2a. So this would be right here. Since a is a positive constant, so minus 2a is negative. Okay, now let's find our y coordinate. Okay, so just 3x minus 2a equals to 0. You'll get x equals to 2 over 3a. So this would be somewhere here. Okay, all right. Let me erase all this. All right, so now we're going to sketch this one. We're going to do it dotted. So, my gosh. And by the way, when you're doing this, please use a ruler. It really helps. Okay. Yeah, so this is the curve, the line of y equals to 3x minus 2a. Since they're asking for the modulus function, we're supposed to reflect the part that's below the x-axis into above the x-axis. So instead of 2a, now new y-intercept would be positive 2a. So it's going to connect here and here, as well as here. Let me complete it for symmetry. Yeah, so let me erase the dotted one now. So this is our final answer. Okay, don't forget to label it for this first part. Let's head on to the next part. Okay, so now, hence or otherwise, we have to solve this inequality. Okay, so one thing to note is the word hence in here. So if you see the word hence in like a part of a question, that means you have to use the answer to the previous part of your question. So by telling us the word hence, they're telling us to use the answer, our graph to solve this equation, or you can do it another way, by squaring both sides. So we're going to focus on the word hence and use the graph to solve this equation. Okay, so let's sketch this function right here, y equals to x plus 5a. I'm going to do it in black. Okay, so x plus 5a, the y coordinate would be 5a, which is like way up here. Okay, and then the x coordinate would be minus, wait, sorry, the x coordinate would be 5a. Okay, so somewhere here. Okay, fine. I'll just put it somewhere here, even though it's not accurate. And then the y coordinate would just be x plus 5a equals to 0, so that's x minus 5a. So that would be somewhere here. And since the steepness of this graph is 1, because the coefficient of x is 1 as compared to this graph where the coefficient of x is 3, this graph would be less steep. So accurately, it should look something like this. Yeah. Let me erase this. Like so, the reason why I didn't pass it through there is because then it might not, intersect with the curve the graph right here. Yeah, so as you can see, if we extend this graph a bit more, there's actually two intersection points in here. So these are the two intersection points that we have to find. So okay, let's switch back to blue. So in order to do this, we're gonna first find this one first. So to do that, we're gonna take the positive branch of this, like without the modulus function, because this is part of the line of y equals to 3x minus 2a. So we'll just equate 3x minus 2a less than x plus 5a. And then for the other branch, this one, we're going to take the negative branch. So we're going to minus 1 to 3x minus 2a less than x plus 5a. Okay. All right. Now we can solve both of these. So let's solve this one first. So let's move x to the other side by subtracting x from both sides. You'll get 2x minus 2a equals to 5a. And now add 2a to both sides. You will get 7a. So for this, you'll get x is less than 7 over 2a. And then for this one, we can divide both sides by -1. You'll get 3x minus 2a. The inequality sign gets flipped, more than x plus 5a. And now we can subtract x on both sides to remove this. This will be 2x minus 2a more than 5a. And you can add 2a to both sides. You'll get 2x is more than 7a. Wait, what? Oh, sorry. So yeah, you're supposed to, sorry for the mistake. It's supposed to be x minus 5a because you're supposed to divide it on both sides. Okay, so add x to both sides, you'll get 4x minus 2a is more than minus 5a. And then add 2a, you'll get 4x more than minus 3a. And then this would give you x is more than minus 3 over 4a. All right, so now we're going to combine these two answers. You can use a number line if you have to, but by combining, we'll get minus 3 over 4a, and between x and 7 over 2a. Let's check our graph. Yeah, as you know, it's not accurate, but it does look roughly correct. Yeah, so this is our final answer for this part. Let's head on to the next question. Okay, so for this question, we're supposed to solve this equation, this logarithmic equation. Okay, so to first solve this, we're supposed to make sure that both sides are expressed in terms of a single logarithm with the same base. So in order to do that, we can first move this 2 into here using our power rule. So this would be ln 2x plus 3 squared minus ln 2x plus 5 equals to ln 3x. And then the right-hand side, we can further simplify by using our law that says ln A minus ln B is equals to ln A over B. So hence this would just be ln 2x plus 3 squared over 2x plus 5. equal to ln 3x. Okay, so now we can just equate these the expressions inside the logarithm. So this would just be 2x plus 3 squared over 2x plus 5 equals to 3x. Okay, and now we can multiply both sides by 2x plus 5. So this would be equal to 3x times 2x plus 5. Let's expand the right-hand side first. So we'll be using a plus b squared equals to a squared plus 2ab plus b squared. So our a would be 2x and the b would be 3. So this would give us 4x squared plus 2 times 2x, that's 4x, times 3, that would be 12x, plus 3 squared, which is 9. And this would be equal to 6x squared plus 3x times 5, which is 15x. All right, now let's move everything to the left-hand side to simplify this into a quadratic. So 6x squared minus 4x squared, that's 2x squared, plus 15x minus 12x, which is 3x, minus 9 equals to 0. Okay, now you can either factorize this to solve or use a quadratic formula. So I'm gonna try factorizing this. So 2x plus 3 minus 9, you will get 2x minus 3 times x plus 3 equals to 0. All right, now equate each factor to 0. 2x minus 3 equals to 0. You will get x equals to 3 over 2 and equate x plus 3 to 0. You'll get x equals to negative 3. Okay, before we accept this as our final answers, we should see if any of the x values lead to real solutions. So let's substitute x equals to negative 3. So you can just substitute into any part of the equation, into any logarithm. So I'm going to substitute it here. And clearly, this gives us ln 3 times negative 3, which is ln negative 9, which is definitely not possible because ln x is only applicable where x is more than 0. So hence, this would be rejected. And by the way, you don't have to show your verification. You can just do it on your calculator or mentally. So we only have one answer, x equals to 3 over 2 as our final answer. Okay, let's head on to the next question. All right, so for this question, we're supposed to find the exact value of this integral right here. So first, let's write down the integral with the limits. So limits is pi over 4, pi over 5, integral of 3 cosine square 5x dx. So first, let's try to express cosine square 5x in terms of a logarithm. I mean, in terms of uh, in terms of in terms of something that you can integrate. So you can actually use your double angle formula, okay, from your MF19 for cosine. So it's right here. So you can see cosine 2a is equal to either this, this, or this. Since we're dealing with cosine square, we're going to choose this. So, so cosine 2a is equal to 2. Okay, you know what? I'm not going to do it here. I'm just going to write it up here. So cosine 2a is equals to 2 cosine square a minus 1. And now we'll make cosine square a the subject. So cosine square a is equals to cosine 2a plus 1 So this would be cosine square A equals to half cosine 2A plus 1. And now just substitute A equals to 5x, you'll get, this would be the final one, 3 times half times cosine 2 times 5x, so that's 10x plus 1 dx. And now you can move this constant term over out of the integral sign. So 3 over 2 would be here. Now you're just going to have to integrate cosine 10x plus 1 dx. Okay, now in order to integrate this, you're going to first take the derivative of 10x and divide it. So you have to put 1 over 10 and sine 10x, since the integral of cosine x is sine x. And then add. Now you have to integrate 1 with respect to x, which is just x. Don't forget to put your limits. All right, now we can put our limits. So pi over 4, we'll get 1 over 10 sine 10 times pi over 4. That is 10 times pi over 4. You'll get 5 over 2 pi plus pi over 4. And this is minus 1 over 10 sine 10 times pi over 5. You'll get 2 pi minus pi over 5. All right, now just simplify. So sine 5 over 2 pi. You don't get an exact answer, don't put it. So we get 1. So 1 over 10 times 1, that's just 1 over 10. Plus, we can subtract these together. So pi over 4 minus pi over 5, you'll get pi over 20 minus 1 over 10 sine 2 pi. So sine 2 pi is 0. So hence, this would just be gone. So expanding everything, we get 3 over 20 plus 3 over 40 pi. So this is our final answer for this question. 3 over 20 plus 3 over 40 pi. Let's head on to the next question. Okay, so for this question, we're told that Z1 equals to R1 times E to the power of I times theta 1, and Z2 equals to R2 times E to the power of I times theta 2. So using this, we have to show that this result is true. Okay, so first of all, let's find what Z1 times Z2 is. Okay, so Z1 is R1 times E to the power of I theta 1 times R2 E to the power of I theta 2. So we can multiply R1 and R2 together and the exponentials together. So e to the power of I theta 1 times e to the power of I theta 2. Okay, so since these are the same base, according to a law of indices, we can just add up the powers. So this is e to the power of I theta 1 plus I theta 2, which you can just write as e to the power of I times I theta 1 plus theta 2. So this is our Z1 times Z2. Now let's find Z1 and Z2 conjugate. Okay, so the asterisk sign just means conjugate. So what a conjugate is that, let's say we have the complex number a plus bi, the conjugate would be, okay, let's be Z. Conjugate would be Z asterisk equals to A minus BI. Yeah, so using this, we can sketch it on our Argand diagram. So this is our real axis, this is our imaginary axis. So we'll let this be A plus BI. So by logic, we can say that A minus BI would be here. And the argument of A plus BI, let it be theta. We can clearly see that the argument of A minus BI is minus theta. So hence, the modulus doesn't change. So R1 times R2 still, but the argument just becomes negative. So this one would just be e to the power of I times minus theta 1 plus theta 2. So this would just be R1 times R2 e to the power of e to the power of minus I times theta 1 plus theta 2. Yeah. Okay, now let's figure out what Z1 conjugate is. Z1 times Z2 conjugate. Z1 conjugate times Z2 conjugate, sorry. Yeah, so as I said, you just use this diagram that we sketched to figure out our complex numbers, the conjugate of them in the polar form. So Z1 is R1 e to the power of negative I theta 1 times R2 times e to the power of negative I theta 2. So this would just be R1, R2 times e to the power of minus I theta 1 plus minus I theta 2. And this would give you R1, R2 equals to e to the power of minus I theta 1 plus theta 2. Yeah, so as you can see, both of them are the same, exact same. And hence we can conclude that Z1 times Z2 conjugate is equals to Z1 conjugate times Z2 conjugate. So we can write shown here. So this is our final answer for this first part. Let's head on to the next part. Okay, so here they told us that Z equals to 3 times e to the power of pi over 4i is a root of this equation right here, where b and c are real. So for this, you have to state the other root and hence find the values of b and c. Okay, so here we have a quadratic equation. So that means we must have two solutions, where one of the solutions is this one. So if we have one, so a quadratic can have, there's three cases. Okay, so first case is real and distinct. You should have learned this in AS. And then second case is equal, two roots, and the third one in AS you would have learned no real roots, but at A level, this is further elaborated upon, where we learned that there's two complex roots, where there's a conjugate, where one is a conjugate. Okay, never mind. So two complex roots. And what's the relationship between these complex roots? They're basically conjugates of each other. So let's say we have a plus bi. The other root would just be a minus bi. Okay, so using this, we can easily find the other root. So to find the conjugate of this complex number, this we can write z equals to, and use this Argand diagram in here. So the modulus remains the same, but the argument changes by -1. So you just have to add -1 to the conjugate, just to multiply it. So this is z equals to 3 times minus 1 over 4 pi I. So this is the other root of this equation. And now using this answer, we have to find the values of B and C. Okay, so first of all, let's let's express these in terms of factors, like make the left hand side 0. So this would give us Z minus 3e to the power of negative 4 pi I. Then times, for this one, you can also move it to the left-hand side. So this would be Z minus 3 times e to the power of 1 over 4 pi I. You can make this equals to 0. Okay, now let's expand everything. So Z times Z, that's Z squared. Z times negative 3 times e to the power of 1 over 4 pi I. That's minus 3Z e to the power of 4 pi I. And then minus 3 times e to the power of negative 4 pi I times Z. That is minus 3Z e to the power of 1 minus 1 over 4 pi I. And then minus, so these two multiplied, minus 3 times minus 3, that's plus 9 times e to the power of minus 4 pi I times e to the power of 1 over 4 pi I equals to 0. Okay, so this is Z squared. This equals to 3Z. You can factor out this, okay? So, e to the power of 1 over 4 pi I plus e to the negative pi over 4 I. And then this is equals to, so this would cancel out, plus 9. Okay, now we have to figure this out. Okay, so to figure this out, oh, okay. The only way I can see doing this is to convert it into Cartesian form. So to do that, we're going to use this expression e to the power of theta equals to x, wait, no. X plus iy, where x is cosine theta and y is I sine theta. So this would give you cosine pi over 4, which is square root 2 over 2 plus sine pi over 4, that's square root 2 over 2 plus cosine negative pi over 4, that is also square root 2 over 2 minus actually plus sine negative pi over 4, which is minus 2 over 2. Yep. Okay, so I forgot to put the I. So the i's, they cancel out. And then square root 2 over 2 plus square root 2 over 2. That would be just square root 2. So this is z squared minus, okay, you know what? Let me double check with the calculator. Yeah, that's just square root 2. So minus 3 square root 2 z plus 9 equals to 0. So we can say that this is our final answer. final equation for this part as well as the entire question. Let's head on to the next question. Okay, so for this question, we're told that the equation of a curve is this. It's expressed implicitly. So for the first part, we have to show that dy dx is equals to this. Okay, so first of all, let's differentiate each side with respect to x. So dx would be x plus y plus y squared times e to the power of negative x. This equals to b dx 4. Okay, now we're gonna differentiate xy first. Okay, so to do that, we're going to use our product rule. So to differentiate xy, we'll first keep x and differentiate y with respect to x. So this would give us dy dx plus x. We're going to differentiate that, so that's y, and that's 1, and we're going to keep y, so plus y. And then this will be plus, we're going to now differentiate y squared times e to the power of negative x. Okay, so again, we're going to use the product rule. So we're going to keep e to the power of negative x and differentiate y squared. So to do that, differentiate with respect to y first, so you get 2y and multiply by dy dx. And you add that with y squared, we're keeping y, times the different derivative of e to the power of negative x. So this is just minus e to the power of minus x equals to the constant, the derivative of a constant is always 0. All right, let's simplify everything in here. So x dy dx plus y plus 2y times e to the power of negative x dy dx minus y squared e to the power of negative x equals to 0. Okay, now let's keep all the terms in dy dx on the left side. So x dy dx plus 2y e to the power of negative x dy dx equals to y squared times e to the power of negative x minus y. Okay, now we're going to make dy dx a subject, so we're factoring it out. So dy dx is x plus 2y e to the power of negative x. And this is equals to y squared times e to the power of negative x minus y. Okay. Now dy dx, it would be equal to y squared times e to the power of negative x minus y over x plus 2y e to the power of negative x. Let's see. Oh, we still haven't reached our answer. So to do this, we're just going to multiply both the numerator and the denominator by ex. So finally, you will get y squared minus y e to the power of x over x e to the power of x plus 2y. All right. So this is our final answer. So we can write shown here since we've shown the result. And yeah, this is our final answer. Let's head on to the next part. Okay, now we're going to find the gradients of the tangents to the curve when x equals to 0. Okay, so whenever you see the word tangent, you should know that the gradient of the tangent always represents a gradient at whatever point it's touching. So hence, for this, you have to find your dy dx. Since we found our dy dx, we just have to substitute in our dy dx. However, you see that our dy dx is also in terms of y, so we have to find the corresponding y value first by substituting into here. So we're going to sub x equals to 0 into equation. Okay, so xy, that would just be 0 plus y squared times e to the power of negative 0. Yep, which is equals to 4. And this is just equals to y squared equals to 4. And you would get y equals to square root 4, which can give you 2 or negative 2. Okay. Now we're gonna substitute our first set of values. So x equals to 0 and y equals to 2 into dy dx. So dy dx will be equal to y squared, that is 2 squared minus y, so minus 2 times e to the power of x. So e to the power of 0, that's 1 over x times e to the power of x. So that's 0 times e to the power of 0, that's 0, plus 2 times 2. So putting all this into a calculator, you get 4 minus 2 over 2 times 2, that's 4. So you get half. So this is our first answer for the first tangent. Now let's substitute our second pair. So we're going to sub x equals to 0 and y equals to negative 2 into dy dx. So dy dx that'll be equal to y squared, which is minus 2 squared, minus y, so minus 2, that's plus 2 times e to the power of 0, which is 1 over x to the power of e to the power of x, that's 0 times 1, which is 0, so 0 plus 2y, so 2 times negative 4, which is minus 4. So putting all this into a calculator, you get minus 3 over 2. So this is our final answer for this part, as well as the entire question. So half and negative 3 over 2. Let's head on to the next question. Okay, so for this question, we're supposed to find the complex number z for which this expression is real and the modulus of z is equal to square root 10. Give your answers in the form z equals to x plus iy, where x and y are real. Okay, so first of all, to solve any complex number equation, you have to let your z equal to x plus iy. So let's use this first piece of information. So sub your x z equals to x plus iy, so x plus iy plus 4 over x plus iy plus 4i. This is equals to x plus 4 plus yi over x plus I times y plus 4. Okay, so to make this into a proper complex number in the form a plus bi, we're going to have to multiply both the numerator and denominator by the conjugate of the denominator. So we're going to do x times x minus I times y plus 4. This would be times x minus I y times 4. Okay, so let's simplify everything. Let's write down. Okay, 4 plus iy times x minus I times y plus 4. Okay, so let's simplify the numerator first. So multiply x plus 4 with x, so you'll get x squared plus 4x. And now we're gonna multiply x plus 4 with minus I times y plus 4. So this is minus I times x plus 4 times y plus 4. All right. Now we're gonna multiply I times y with x. So this is I xy, and then this is iy times negative I times y plus 4. So we'll get minus I squared. And I squared is just equals to -1. So negative times negative, you'll get positive. So this is just positive y times y plus 4. Okay, now let's simplify the denominator. So for this, we're going to use the shortcut way. So as you can see, since both of them are conjugates, we can write them in the form a plus b times a minus b. And there's a formula for this, which will give us a squared minus b squared. So our a would be x, so x squared minus b squared. So b is I times y plus 4. So b squared would give you I squared times y plus 4 squared. So minus I squared, that gives you plus y plus 4 squared. All right. And now let's simplify everything here. So x squared plus 4x plus y squared plus 4y plus I times, we can expand x plus 4 times y plus 4. You'll get x, y times plus 4x plus 4y plus 16. Wait. Oh, sorry, this is minus I and then plus x, y. Yep, over. Yeah, let's keep this unsimplified like this. Okay, now, okay, wait a minute. Oh, this is minus, so xy and xy cancel out. So you would get x squared plus 4x plus y squared plus 4y uh, plus I bracket minus 4x minus 4y minus 16 over x squared plus y plus 4 squared. Okay, and now we're going to split this up. So we're going to split the real and imaginary term. So this would give us x squared plus 4x plus y squared plus 4y over x squared plus y plus 4 squared plus I times minus 4x minus 4y minus 16 over x squared plus y plus 4 squared. Yeah, so this is our final expression for this. And since they said this is real, this means our imaginary part must be equal to 0. So we're going to equate minus 4x plus 4y plus 16 over x squared plus y plus 4 squared to 0. So multiplying by negative times the -1 times the denominator, you'll get 4x plus 4y equal plus 16 equals to 0. And you'll get 4x plus 4y equals to negative 16. Now divide by 4, you'll get x plus y equals to minus 4. And hence, x would just be equals to minus y minus 4. So this is our first equation. Now let's make the second equation. So here it tells us the modulus of z is square root 10. And we know the modulus of z, where z equals to x plus iy, is given by the square root of x squared plus y squared. So we'll just equate square root of x squared plus y squared equals to square root 10. This gives us x squared plus y squared equals to 10. Okay, now this is our equation 2. We'll substitute our 1 into 2. So x squared is minus y minus 4 squared plus y squared equals to 10. And then minus y is a, so a squared is y squared minus 2 times a, which is minus y, times b, which is 4, plus 4 squared, which is 16. And then, okay, let's move the 10 over to this side. So minus 10 plus y squared equals to 0. So y squared plus y squared would be 2y squared. And then minus 2 times minus y, that's plus 2y. And then 2y times 4, you'll get 8y plus 16 minus 10, it'll be 6. That's equals to 0. And then this would be y squared plus 4y plus 3 equals to 0. So now we're going to solve this equation. Okay. So you can either factorize or use the quadratic formula. So I'm going to factorize it first. Okay, so you get y plus 1 times y plus 3 equals to 0. So therefore, you will get y equals to negative 1 and y equals to negative 3. So these are our y values. Okay, let's use this space right here. Okay, so sub y equals to negative 1 into the first equation. So this would give us x equals to negative negative 1. So 1 minus 4, this would be minus 3. And now we'll sub y equals to negative 3 into 1. So this would give us x equals to 3 minus 4. So this is minus 1. Hence, our complex number z would be z equals to x plus iy. So x is minus 3 and then y is minus 1. So minus 3 minus I and z equals to x is minus 1 minus 3i. So these are our final answers for this question. And if you want to check whether your answers are correct, you can just substitute these complex numbers, back into this equation and see if you get a real answer by using the complex mode in your calculator. And you can check whether the modulus is correct by typing in the modulus into the calculator and see if you get square root 10. So with that, let's head on to the next question. Okay, so for this question, we're going to let fx, we have to let fx be equals to this, where a is a positive constant. And for the first part, we're supposed to express fx in partial fractions. All right, so to do this, let's first write our fx in the original expression. And let's split the denominator up. So one of the terms, the denominator is going to be 3a plus 2x. And for the numerator, since the denominator is a linear term, numerator would be a constant term. So we'll let it be a, and then now write down the second denominator, the second term in the denominator. So since this one is since the denominator is a linear term, then the denominator is going to be b. It's going to be a, constant. Yeah. So this is what we have to set up. Now let's multiply both sides of the equation by the denominator of fx. So this would give you 3a minus 5x equals to a times 2a minus x plus b times 3a plus 2x. Okay, now let's so now what we have to do is we're going to choose a value of a that makes either one of these factors 0. Then we only have to solve for one of the unknown constants. So first we're gonna substitute x equals to 2a. It will make the first factor 0. So we only have to find b. So this is b times 3a plus 2 times 2a, which is 4a, equals to 3a minus 5 times 2a, that's minus 10a. This would give you 7ab equals to minus 10a plus 3a, which is minus 7a. So we can cancel the a's out. We'll have 7b equals to minus 7. Hence, b is equals to minus 1. So this is the constant b. Now we have to find a. So in order to find a, we're going to have to make 3a plus 2x equals to 0. And to make it 0, we have to substitute x equals to minus 3 over 2a. So if you can't figure out what value of x you have to substitute, you can just equate the factor to 0. So here, yeah, you can let it be 0 and then just solve for x. So here you'll get x equals to minus 3 over 2a. Okay? Yeah. So substituting that, you will get a times 2a minus plus 3 over 2a equals to 3a minus 5 times negative 3 over 2a. Okay, and then 2a plus 3 over 2a, that's 7 over 2a times big A equals to 3a plus 15 over 2a. So this is 21 over 2a. So the a's cancel out, and you get 7 over 2a equals to 21 over 2. You'll get a equals to 21 over 2. Divide by 7 over 2, you'll get 3. So this is this is the value of a for this part. Now we can express fx, okay, in terms of partial fractions. So fx would be 3 over 3a plus 2x minus 1, since b is minus 1, so and put the minus sign in here. So 1 over 2a minus x. So this is our final answer for this first part. Okay, let's head on to the next part. Okay, so for this second part, we're told hence we have to obtain the expansion of fx in ascending powers of x. So that means first term should be a constant, and the second term should be a term in x, followed by a term in x squared, and so on, up to and including the term in x squared. So we need constant term in x, and x squared only. Okay, so again, we can see the word hence, right? So that means we're gonna have to use the answer from the previous part. So let's write down fx first to make this easier. So 3/3a plus 2x minus 1/2a minus x. Okay, then we can write this as negative power. So we can use the relationship 1/a equals to a to the power of -1. So this would be 3 times 3a plus 2x to the power of -1 minus 1 times 2a minus x to the power of -1. Okay, so to do this, we're gonna have to use this formula for binomial expansion, okay, where n is rational, so that means n cannot be a whole number, has to be either negative or a fraction, and modulus of x is less than 1. So since we only want the term in x squared, we only need this part of the formula, 1 plus nx plus n times n minus 1 over 2 factorial x squared. So one criteria for using this formula is we have to make the constant term 1, which you can do by factorizing by dividing the constant term by whatever it is. Okay, so let's factor out 3a. So this would be 3a times 1 plus 2/3a x to the power of -1. And then this is minus 1 times, so we have the constant term is 2a. So we'll take 2a out times 1 minus 1/2ax, all to the power of -1. Okay, now we're going to distribute the powers using this indices law. Okay, so if you have a times b to the power of n, you can write it as a to the power of n times a b to the power of n. So this 3a would be 3a to the power of -1, which you can rewrite as 1/3a times 1 plus 2/3a x to the power of -1. And then for this one, we're gonna use the same law. So this is just minus 1/2a times 1 minus 1/2a x to the power of -1. All right, so 3 times 1/3/a, that is 1/a times 1 plus 2/3ax to the power of -1 minus 1/2a times 1 minus 1/2ax to the power of -1. Okay, so now we're ready to expand since constant term is 1. So the first term would just be 1 plus nx. So in this case, n is -1. So -1 times x. So x is 2/3ax. So -1 times 2/3ax plus n. So n is -1, and -1 is 1 minus 1, so -2/2 factorial x squared. So x squared is 2/3a x squared. And then this would just be minus 1/2a times 1 plus nx, so n is minus 1. Yeah, so n is minus 1, and x is minus 1 over 2ax. So this is plus 1 over 2ax plus n, which is minus 1, times n minus 1. So minus 1 times minus 1, minus 2 over 2 factorial times x squared, which is 1 over 2ax squared. All right, so this would just be 1 over a times 1 minus 2 over 3ax. So this whole thing would just be 1. This whole thing would be 1, so we just get 2 over 3ax whole thing squared. So 2 over 3a, that is 4 over 9a squared times x squared. Again, we're using this formula here. And then the next one, get 1 plus 1 over 2ax. This whole thing becomes 1, so you just get minus 1 over 2ax to the power of 2. So 1 minus 1 over 2a squared, you get 1 over 4a squared x squared. All right, now we get 1 over a minus 2 over 3a squared x plus 4 over 9a cubed x squared minus 1 over 2a minus 1 over 4a squared x minus 1 over 8a cubed x squared. Okay, now let's take the constant terms first. So 1 over a and 2 over a. So 1 over a minus 1 over 2a. Now the x terms, so minus 2 over 3a squared and minus 1 over 4a squared x and plus 4 over 9a cubed x squared minus 1 over 8a cubed x squared. So this 1 over a minus 1 over 2a, we'll just get 2 over 2a. So that is 1 over 2a. And then this one, you will get, you can just take out the minus 1 over a squared. So that's just 2 over 3 plus 1 over 4. You get 11 over 12. So 11 over 12 a squared minus 11 over a 12 squared. And then for this one, it's just 4 over 9a cubed minus 1 over 8a cubed. So for this, you will get 23 over 72 a cubed. Oh, sorry, forgot to put the x here. X squared. Yeah. So this is our final answer for this whole part. Let's head on to the next and final part. Okay, so for this final part, we're supposed to state the set of values of x for which the expansion in part B is valid. All right, so let's go back to our MF19. So let's take a closer look at this part. So here they say that modulus x must be less than 1. So like the x in here has to be between 1 and -1. Okay, so in our expansion, we expanded this as well as this. So the condition should be that 2 over 3a x must be between 1 and -1, and that 1 over 2ax must also be between 1 and -1. Yep. Okay. So let's multiply by 3a. So you get 3a and 2x, 3a. Now dividing by 2, you get minus 3 over 2a x, 3 over 2a. And then this one, just multiply by 2a, you'll get minus 2a x, 2a. So we have to see which one is like a subset of which one. So, okay, basically we have to see which inequality satisfies both inequalities. So this is within this one, but this is not within this one. So we're going to reject this, and hence x is between minus 3 over 2a and 3 over 2a. Okay, so this is our final answer for this part. Let's head on to next question. Okay, so now we're supposed to prove the identity cotangent square minus tangent square is equal to 4 cotangent 2 theta plus cosecant 2 theta. All right, so in order to prove this identity, you have to choose like the more complicated one. So I can see that the right side is more complicated, so we'll start from there. So let's write that down. So for this, my first instinct would be to use the difference of squares. So a squared minus b squared. Can write it as a minus b times a plus b. So hence this would just be cotangent theta minus tangent theta times cotangent theta plus tangent theta. Okay, now, okay, let's see what we can do. All right. Now we're just going to express everything in terms of cosines and sines. Okay, so cotangent theta we know is equals to cosine theta over sine theta, so write it like that. And then minus tangent theta, which is just sine theta over cosine theta, times cotangent theta is cosine theta over sine theta plus sine theta over cosine theta. So we can we can make the denominator the same. So for this one, we just multiply by cosine theta. So you get sine theta, cosine theta. So cosine theta times cosine theta, you get cosine squared theta minus sine theta, sine theta. So minus sine squared theta. Then this is times, again, the denominator would be sine theta, cosine theta. And then cosine theta times cosine theta is cosine squared theta plus cosine theta times sine theta. Sine theta times sine theta, that's sine squared theta. All right, now we can simplify this further. So we know, like, okay, now what we can do is to express these in terms of double angle formulas. So for cosine squared minus sine squared, we actually have an identity for that. So it's right here. You can see it's equals to cos 2a. So hence, we can just write this as cosine 2 theta. As well as for sine theta, cosine theta, we also have an identity very close to it. So you can see sine 2 theta is 2 sine a cosine a. So hence, sine a cosine a is just half sine 2a. So this is just half sine 2 theta. times cosine squared plus sine squared, that's 1 over half sine 2 theta. Now let's simplify this. So 1 over half, that is 2. And then cosine 2 theta over sine 2 theta, that's cotangent 2 theta. And then 1 over half, that is also 2. And 1 over sine 2 theta, you will get cosecant 2 theta. Okay? Yeah, so you can see we're getting very close to this. So 2 times 2 is 4. And this is cotangent 2 theta, cosecant 2 theta. So this is our final answer, and we should write proven since the result is already given. So yeah, so we can now head on to the next part. All right, so for this part, we've told hence to solve this equation for this domain of x between 0 degrees and 90 degrees. Okay, so again, they have the word hence in here. So that means we have to use our answer from the previous part in here. So let's see what we can do. Yeah, so you can see on the right-hand side, we have cotangent squared minus tangent squared, which is the same as this. So we can just equate it to this. So let's write that down. So for cotangent 2x times cosecant 2x equals to 5 secant 2x. Okay, so what I like to do is to express this in terms of cosines and sines. So cotangent 2x is just tangent 2x, is cosine 2x per sine 2x. And then cosecant 2x is sine 2x again, so sine 2x and sine 2x is just sine square x. This is equal to 5 over cosine 2x. Okay, so now let's cross multiply. So for cosine 2x times cosine 2x, that's for cosine square 2x. This is equals to 5 sine square 2x. All right. Should we? So, so we can divide both sides by cosine squared 2x. So this would give us 4 equals to 5 sine squared 2x over cosine squared 2x, 5 tangent squared 2x. And then we can write tangent squared 2x equals to 4 over 5. Okay, so let's take the square root. So we get tangent 2 squared 2x is equals to square root 4 over 5, or we get tangent 2x is equal to minus 4 over 5. Okay, so let's see if we have to reject any values. And to do that, we're gonna have to look at our range for x. So, okay, so first of all, since our tangent is in terms of 2x, we have to change this to 2x. So this is 2x between 180 degrees and 0 degrees. Okay, so this is the range that we're supposed to be working with for now. So we have to see if like any angles in this range give us a negative value for tangent. So let's draw a unit circle. Okay, so this is A. That means all the ratios are positive. This is S. only sines positive, T only tangent positive, and C only cosines positive. So here, tangent is positive, while here tangent isn't positive. And our range, which is between 0 and 180 degrees, only covers these first two quadrants, okay? So yeah, so our tangent to x can be both positive and negative. So let's do the positive one first. So for this 2x, it's going to be right here, okay? So 2x would be equal to tangent inverse square root 4 over 5. Yeah, and then x would be equal to half tangent inverse square root 4 over 5. And this would be equal to, don't forget, just type into your calculator and make sure to change your calculator into degree mode because our domain is given in degrees. Oh, sorry. So you will get 20.9 degrees to one decimal place. This is the first answer. Now let's solve the second one. So for the second one, since our tangent is negative, it's going to line the second quadrant. So it's going to look something like this. It's going to be an obtuse angle. And by taking the inverse of the modulus of minus square root 4 over 5, you'll get the basic angle alpha. Hence, to get 2x, you have to first take 180 and minus tangent inverse square root 4 over 5. You have to take the positive value of this. Now we can divide the whole equation by 2. So 180 divided by 2, you get 90 minus half tangent inverse square root 4 over 5. So type it into a calculator. Again, make sure calculator is in degree mode. You will get 69.1 degrees to one decimal place. So these two are our final answers for this question. And if you want to check this question, the answers again, you can substitute the exact values back into both sides of the equation and see if they match or not. So with that, let's head on to the next question. Okay, so for this question, we're told that with respect to the origin O, the points A, B, and C have position vectors given by OA as this, OB as this, and OC as this. And we're also told that the line L passes through B and C. So for the first part, we're told to find a vector equation for L. Okay, so first let's draw a sketch of L. So we know that L passes through B and C. Hence, our vector equation will include a position vector of one of the points on the line. So it can be either B or C. So I'm going to choose B. So hence, this is going to be R equals to OB. So 1, 3, minus 2 plus lambda. This is going to be a direction vector for line L. So we can take BC as an example. So, okay, you know what? Let me cancel this out. So BC is going to be OC minus OB. So OC is 2 minus 1, 3 minus OB. That's 1, 3 minus 2. That's equals to 1 minus 4, 5. Okay, so this is our direction vector. Now we can write the full form as R equals to 1, 3 minus 2. That's OB plus lambda times 1 minus 4, 5. Okay, so this is our final answer. And to be safe, write it in IJK format as well. So I 3J minus 2K plus lambda times I minus 4j plus 5k. So yeah, these are our final answers for this first part. Let's head on to the second part. All right, so for this part, we're told that the point P is the foot of the perpendicular from A to L, and we have to find the position vector of P. Okay, so to do this question, let's sketch, you know, a diagram. So this is L, and this is the point A, and the perpendicular is something like this. Okay. Now, what do they mean by the foot of the perpendicular? So that's basically the intersection point between the line connecting A to L and L, like this intersection point right here. So we have to find the position vector of this. All right, so first of all, let's find the coordinates of P using our vector equation. So OP would just be equals to 1, 3, minus 2, plus lambda 1 minus 4, 5. This would be equal to lambda plus 1 and 3 minus 4 lambda, 5 lambda minus 2. Yeah, so this is the position vector OP in general. Like this is any point along the line L in its general form. So we'll let OP be this first. Okay, now let's find AP. So AP is just OP minus OA. So lambda plus 1, 3 minus 4 lambda, and 5 lambda minus 2 minus OA. So OA is 1, 2, 0, 1, 2, 0 equals to lambda and 1 minus 4 lambda and 5 lambda minus 2. Okay, so this is AP. And now we're going to use our scalar product. So since these are meeting at perpendicular lines, the dot product of AP and L should equal to 0 because cosine 90 is equals to 0. You can take a look at your scalar product formula right at the very end. Yeah, so cosine theta is the angle that they meet. All right. Okay, now, so let's find our dot product. So lambda 1 minus 4 lambda, 5 lambda minus 2 dotted with L. So L is 1 minus 4, 5 is equals to 0. Lambda times 1 is lambda, minus 4 times 1, that's minus 4. And minus 4 times minus 4 lambda, that's plus 16 lambda. Plus 5 times 5 lambda, that's 25 lambda. 5 times negative 2, that's minus 10, equals to 0. Now we're going to find our lambda. So lambda plus 16 lambda plus 25 lambda, you get 42 lambda. And move all the constant terms to the other side. So 4 plus 10, you'll get 14. Hence, lambda will just be equals to 14 divided by 42, 1/3. So this is our lambda. Now we can substitute back into the position vector of OP. So hence, OP would just be equals to lambda plus 1, so 1/3 plus 1, 3 minus 4 lambda, so 3 minus 4, 1/3, and 5 lambda minus 2, so 5 times 1/3 minus 2. This is equals to 4 over 3. 3 minus 4 over 3, that's 5 over 3. And 5 over 3 minus 2, that's minus 1/3. So we can factor out 1/3 to get 1/3 times 4, 5 minus 1. So this is our final answer for this part. Let's head on to the last part. Okay, so for this final part, we're told that the point D is a reflection of A in L, and we have to find the position vector of D. Okay, so what do they mean by a reflection of A in L? So this is our line L, and this is the point A, and this is the point D. So by reflection, it basically means that the perpendicular distance from D to L is equal to the perpendicular distance from A to L. So basically dP, and the length of dP is equals to the length of PA. And therefore, you can also say that the vector AP is equal to the vector PD, since they are collinear, they have the same magnitude, and they are going in the same direction. Okay, so AP is equals to PD. So AP is lambda, okay? So lambda is 1/3, 1 minus 4 lambda, so 1 minus 4 over 3, 5 lambda minus 2, so 5 over 3 minus 2. Let me see if I did it correctly. Okay. Yeah. Yeah, so this is PD, so 1/3. 1 minus 4 over 2, that's minus 1/3. And 5 over 3 minus 2, that's minus 1/3. So yeah, so this is AP. This is PD. Now we can form an equation for PD in terms of OD and OP. So PD is obviously just OD minus OP. So hence OD is equals to PD plus OP. So PD is 1/3 minus 1/3 minus 1/3 plus OP, which can use our previous part. So let's use the unsimplified one. So 4/3, 5 over 3 minus 1/3. Okay. Yeah. So adding these up, you will get 1/3 plus 4/3, you get 5/3, and minus 1/3 plus 5/3, you get 4/3, and minus 1/3 minus 1/3, you get minus 2/3. Then hence the final answer will be 1/3 times 5, 4 minus 2. So this would be our final answer for this part, as well as the entire question. Let's head on to the next question. Okay, so for this question, we're told that the variables x and y satisfy the differential equation, this, okay? And we're also given the initial conditions, y equals to pi over 12 and x equals to pi over 2. So for the first part, we have to solve the differential equation, obtaining a relation between x and y. So we don't have to make either x or y the subject. Okay, so let's write down the dE. So sine 4y dy dx equals to x sine 2y sine 3x. Yeah, so now we're going to separate the variables. So we'll move all the y terms to the left. So it'll be sine 4y over sine 2y dy dx is equals to x sine 3x. And now we're going to multiply dx on both sides. So this is sine 4y over sine 2y dy equals to x sine 3x dx. And now we can integrate both sides. So first, let's integrate the dy, the right-hand side, the left-hand side. So sine 4y over sine 2y with respect to y. So this is going to be, so sine 4y we can rewrite as sine 2 times 2y over sine 2y. And we can use the double angle formula for sine, okay? So, yep, it's right here, sine 2a is equals to 2 sine a cosine a. And in this case, a is equals to 2y. So this is basically just 2 sine 2y cosine 2y over sine 2y dy. So the sine 2y's cancel out. We'll just get 2 cosine 2y dy. Okay, and now we can take out 2 and just integrate cosine 2y. So to do that, you take the derivative of 2y, okay, and then you divide it. So you take 1 over 2, and then you get sine 2y. Because again, the integral of sine, the cosine is sine. Okay, so simplifying, you'll just get sine 2y. Yeah, so this is the left-hand side done. Now we'll do the right-hand side. Okay, so right-hand side is x sine 3x dx. So to integrate this, since this is a product of two functions, which you can solve by substitution, we have to do this by parts, okay? So here, we're going to let u be equals to x using this rule, liate, okay? So whatever comes before, you have to let that be u. So we have the algebraic function and the trig function. Since algebraic comes before trig, you have to let the algebraic be the u. So hence, u is x and u dx would be 1. And then dv dx is equals to sine 3x. And hence v would just be minus 1/3 cosine 3x. Again, since integral of sine x is cosine x, minus cosine x, sorry. Yeah, so hence the final answer would be u times v, so minus 1/3 x cosine 3x minus integral of minus 1/3 cosine 3x times du dx, which is just 1, so dx. Okay, so we can simplify this. Let's take out the minus 1/3. So this is minus 1/3 x cosine 3x plus 1/3 integral cosine 3x dx. Okay, so integrating cosine 3x. you will just get 1 over 3. Since again, derivative of 3x is 3, so you divide by that and sine 3x. Since cosine 3x integrated is sine x. Okay, and then the final answer will be 1/3 times 1/3. That's 1 over 9 sine 3x minus 1/3 x cosine 3x. Okay, and now we can equate both of these. Okay, so sine 2y equals to 1 over 9 sine 3x minus 1/3 x cosine 3x. Okay, and in case if you're wondering why did I leave out the constant of integration, well, for the dE, you can just put them on either one side. Since, even if you remove the constant of integration from one side, it will go on to the other side. So I'm just gonna let it be in here. Okay? All right. Now we can substitute our initial conditions. So we will sub y equals to pi over 12 and x equals to pi over 2. Yeah. And this would give us sine pi over 6 plus c equals to, yep, 1 over 9 sine 3 over 2 pi minus pi over 6 cosine 3 over 2 pi. Okay, all right. Now let's evaluate all this to sine pi over 6. Okay, pi over 6, you'll get 1/2 plus c, and sine 3 over 2 pi, we'll get -1, so -1 times 1 over 9, that's -1 over 9, and minus pi over 6 times cosine 3 over 2 pi, you will get 0. Hence, you'll get 1/2 plus c equals to -1 over 9. Hence, c is -1 over 9 minus half. This would give you -1 over 9 times minus half, minus 11 over 18. So this is our c. And now we can write our final answer as sine 2y, sine 2y minus 11 over 18 plus 1 over 9 sine 3x minus 1 over x cosine 3x. We can add 11 over 8 on both sides, so you'll get sine 2y equals to 1 over 9 sine 3x minus 1/3 x cosine 3x plus 11 over 18. So this is our final answer for this part. And as the question says, we just have to obtain a relation between x and y. So we have to express it in terms of y. All right, so with that, let's head on to the final part. Okay, so for this part, we're told that y is between 0 and pi over 2. We have to find the values of y when x equals to 0. All right, so first let's substitute x equals to 0. So you'll get sine 2y equals to 1 over 9 times sine 0, which is just 0, minus 1 over 3 times 0 times cosine 3 times 0 plus 11 over 18. Okay, and then this give us sine 2y equals to 1 over 9 times 0, that's 0. Everything is 0, so you just get 11 over 18. Okay, so to solve this equation, let's take note of the domain given here. Okay, so since our sign is in terms of 2y, we also have to change it. So 2y becomes between pi and 0. All right, and now we can draw a unit circle. So for the first quadrant, all is positive, so sine's positive, and second quadrant, only sine's positive. Okay, and since 2y is between 0 and pi, which is the same as 0 degrees and 180 degrees, these are the only two quadrants that we have to be focusing on. Yeah. So since our sine is positive, and it lies between, this range, we can find our 2y. So this is 2y. Okay, this is the first answer. So 2y would be equals to sine inverse 11 over 18, and y would be equals to half sine inverse 11 over 18. So this would be half sine inverse 11 over 18. Okay, don't forget to set to radians, so 1.329 to 3SF. And then the second answer, 2y would just be equals to 180, which is pi, minus sine inverse. So the second one would be an obtuse angle, and this would be the basic angle, which is given by sine inverse 11 over 8. Okay, and then hence y would just be pi over 2 minus half sine inverse 11 over 18. And this would give us pi over 2 minus answer. We would get 1.24 to 3SF. So these two are our final answers for the second part, as well as the entire question. Let's head on to the final question. Okay, so for this question, we're given a diagram which shows the curve y equals to square root x sine 2x for x between 0 and pi over 2. And we're also told that the curve has a maximum point at m, where x equals to a. So first we have to show that tangent to a is equals to minus 4a. All right, so to start off this question, we're going to make use of the second piece of information, maximum point at m. So maximum point is a stationary point, so hence at that point dy dx would equal to 0. Okay, so first step, let's find our dy dx. So y is equals to square root x, so x is the power of half times sine 2x. Okay, and now to find dy dx, we're going to use our product rule since this is a product of two functions. So we're going to keep x to the power of half and differentiate sine 2x. So to differentiate, you take the inner function 2x and differentiate that, multiply. So we put 2x here and cosine 2x, since derivative of sine x is cosine x. Okay, and then plus the derivative of x half, x to the power of half. So this is half times x to the power of half minus 1. So minus 1 plus half, that is, forgot what is it? Let me check. Minus 1 plus half. That's just minus half, and this is sine 2x. Okay, now let's rewrite in terms of square roots. So this is 2 square root x cosine 2x plus 1 over 2 square root x, because, x minus n is 1 over xn. So 1 over x to the power of half is just 1 over square root x sine 2x. Now we're going to equate this to 0. All right, so to solve this, we're going to multiply the whole equation by 2 squared x. So this will give you 2 squared x times 2 squared x. You'll get 4x cosine 2x plus sine 2x equals to 0. All right, and now let's sub x equals to a, since we know that a is definitely a solution to this equation. So this would give you 4a cosine 2a plus sine 2a equals to 0. So let's factor out the cosine 2a. You'll get 4a plus tangent 2a equals to 0. And hence, cosine 2a is equals to 0. And 2a would give you pi over 2. And a would be pi over 4. However, if you look back at our diagram, pi over 4, it would be the halfway point here, okay, which m is definitely not, so we're going to reject this. Or you can have 4a plus tangent 2a equals to 0, and matching the form given in our question that we have to show, we'll get tangent 2a equals to minus 4a. So this is the given result that we have to show, so write shown. And this would be our final answer. Let's head on to the next bit. Okay, so for this second part, we have to show by calculation that 0.9 is between, a is between 0.9 and 0.95. All right, so how I like to do this type of question is to make one side equals to 0. So that would mean adding both sides by 4a. So tangent 2a plus 4a equals to 0. All right, and now we're going to substitute a equals to 0.9. So tangent 2 times 0.9 plus 4 times 0.9 would be equal to, don't forget to set it to radians. Since a is in radians, you'll get a negative answer. So express it to 3s, so minus 0.686 to 3sf. And now substitute a equals to 0.95. So this would be tangent 2 times 0.95 plus 4 times 0.95 equal to 0.873 to 3sf. So as you can see, from 0.9 to 0.5, our answer changed from negative to positive, okay? So hence, we can say that since there was a sign change, um, 0.9 is between a and 0.95. So this is the final answer for the second part. We have to write shown. Let's head on to the next part. Okay, so here we have to show that if a sequence of values is given by this iterative formula and it converges, then it converges to A. So even though the wording might look confusing, they just want you to prove that this iterative formula actually is equal to the original equation that we derived in A, like when you simplify and manipulate it. So let's write down the iterative formula. So x equals to half times pi minus tangent inverse 4x bracket. Let's multiply both sides by 2. So 2x equals to pi minus tangent inverse 4x. Now we're going to make our tangent inverse 4x the subject. So tangent inverse 4x would be equal to pi minus 2x. Take tangent on both sides, you'll get 4x equals to tangent pi minus 2x. All right, so for this, to simplify, you can use the tangent, addition formula. So we're going to use the subtraction formula. So tangent A minus B is equals to tangent A minus tangent B over 1 plus tangent A tangent B. Yeah, so this is tangent pi minus tangent 2 squared over 1 plus tangent pi tangent 2 squared, 2x, sorry. Yes, so simplifying this, tangent pi is 0, so minus tangent 2x over 1 plus 0 times tangent 2x, so that's just 1. This is equals to minus tangent 2x. Let's see. Okay, we're very close. Just make tangent 2x a subject, so you get tangent 2x equals to minus 4x. And here you can conclude that hence it converges to A. Shown. So this is our final answer for this part. Let's head on to the final part. Okay, so now we just have to use this iterative formula to calculate A to 4 decimal places, and each result of each iteration should be given to 6 decimal places. All right, so let's choose an initial value. So since A is between 0.9 and 0.95, we're just going to choose the middle value. So that is 0.925. Yep, 0.925. Yeah. So we're going to choose that. So this is A1 and A2 would be. So to do this question, you let your initial value be the answer, like in your calculator. And then you type your iterative formula. So half times pi minus tangent inverse 4 times answer. And then you press the equals button one time, you will get your first iteration. So first iteration would be 0.917380. Bear in mind that each iteration would obviously be different, like initially, depending on what your initial value is. Okay, and then to get the second one, you press the equals button again. So you get 0.918425. And we're going to do this again and again until our values start getting closer and closer. Or if you really want to make sure, you can do it until the values are exactly the same. Okay, so this time I got 0.918281. And then the next value, I got 0.918301. So as you can see, the values are starting to get more consistent. Okay, but we're not going to stop. And this one is 0.918298. And as you can see, it's still not equal to, but if you can see, when you round it off to 4 decimal places, you will get 0.913, which is the same result as the previous iteration when you round it off to 4 decimal places. Hence, we can say that our final answer is equals to, A is equals to 0.9183 to 4 dp. So this is our final answer for this part, as well as the entire question. And we have also come to the end of this paper. So I hope you found this video. Helpful. And if you found it helpful, please make sure to like and subscribe and share this video with anyone else who might find this video helpful. And if you have any questions or queries or what other papers you want me to do next, feel free to leave them down in the comments below. And I'll see you all again next time. Okay, thank you.